Hi everyone, this is Mr. UK, and welcome to this video. We're going to talk about how to find inverse trig values without the use of a calculator. So we've already, up to this point, if you're watching this video, have done a problem similar to the one that I have here listed as cosine of 5 pi over 6. So just a reminder of the process. We have our trig toolbox off to the right-hand side as reference for us. We're going to first ask ourselves where 5 pi over 6 lies in the coordinate plane, and that is going to lie in quadrant number 2. And because of that, that means that cosine is going to be a negative value. The second question we ask is what reference angle is 5 pi over 6? And since it's pi over 6 or 30 degrees away from 180, our reference angle is 30. So we're going to essentially answer the question, what is cosine of 30? Cosine of 30 is root 3 over 2. We put those together and we say our answer is negative root 3 over 2. So given an angle and given a trig function, we can now evaluate its ratio at these special angles. This video is actually going to work backwards. So instead, our new scenario is now we're going to give you the ratio. We're going to say what ratio or trig function we're actually working with, in this case cosine, and your job is to find the angle instead. So we're going to have to ask these questions, but in reverse. So what I mean by that is we're going to first note that this ratio is negative. So we have to ask ourselves, where is cosine going to be negative? Well, cosine is going to be negative in quadrant 2, as we already discussed up above, but there is one other place where cosine is negative, and that is going to be in quadrant 3. So one thing that we're going to keep in mind when we do our problems here is that there are most likely going to be two answers to these problems because there are two values of theta that are going to give us negative root 3 over 2 in this situation. Now, the second question is a little tougher. We're going to just look at the number root 3 over 2, and we're going to look at our reference triangle and say, what angle, when you take its cosine, is going to be root 3 over 2? So if I look at my trig toolbox, I see root 3 and 2 there. If I look at 30 degrees, I see that root 3 is my adjacent and 2 is my hypotenuse. So this is telling me that my reference angle is going to be 30 degrees. So we're going to take that reference angle and we're going to apply it to each of those quadrants. In quadrant number 2, an angle that has a reference of 30 degrees is 180 minus 30 or 150. In the world of radians, that's 6 pi over 6 minus pi over 6. And so my first answer is 5 pi over 6. That should make sense because it matches what we initially did above. Now the quadrant 3 answer is going to be 30 degrees more than 180, or in the radian terms, it's going to be pi over 6 more than 6 pi over 6. So the other answer here would be 7 pi over 6. So we're going to keep that in mind as we go through problems. And this new scenario of finding theta is going to be exactly what we're going to discuss for the remainder of the video. We're just going to look at some different scenarios now. So let's go ahead and move down into those examples and actually take care of this. Now, at any point, if you want to pause the video and try it yourself before you hear my explanation, I highly suggest you do that to give yourself a chance to see what you might be able to do on your own before you get the guidance. So let's start with letter A. First question we're going to again ask ourselves here is we have a positive ratio. So we're going to ask what quadrant is sine going to be positive in? Sine is positive in quadrant 1 and quadrant 2. We can use our reference trig toolbox to the right to help us with that. The ratio for sine is 1/2, so which reference angle has a sine equal to 1/2? Well, 1 and 2 looks like it's going to be 30 degrees. In radians, that's pi over 6. So my two answers for, now they're using x here instead of theta. Sometimes that is going to happen, so let's go ahead and use x as they've mentioned here. So the angle x is going to be equal to, in quadrant 1, 30 degrees, which is actually just pi over 6 itself. And then quadrant 2's answer, 30 degrees, is going to be 6 pi over 6 minus pi over 6. So the equivalent angle is 5 pi over 6. Now, initially, as you're doing these, if it helps to write the degree answer first, and then that will help maybe jog your memory what the radian is, by all means, go ahead and do that. All right, let's move on to the next one. So the next example is a little trickier because we're dealing with a reciprocal trig function. But I have good news. My recommendation here is let's go ahead and find its reciprocal and then work from there instead. So an equivalent equation here would be, instead of writing secant x, we're going to write cosine of x. And then instead of writing root 2, we're going to flip it and call it 1 over root 2. Now that we're in a more familiar trig ratio, let's go ahead and answer those questions. So cosine is positive in quadrants 1 and 4. And since it's 1 over root 2, that looks to me that's coming from the 45, 45, 90 triangle. So that's going to be, oh, I kind of jumped ahead here. 1 over root 2 ratio is indicating that it's 45 degrees, which is also in radians, pi over 4. So my two answers for this question for x is going to be quadrant 1 is just going to be pi over 4. And then in quadrant 4, we're going to be pi over 4 short of 8 pi over 4. So 7 pi over 4 is my other answer choice. All right, let's keep on moving here. We're going to come back to this one because there's another wrinkle we need to address, and that is the fact that we have root 2 over 2 here. Now, if I bring over my trig toolbox, seeing the root 2 should give me a major hint that we're working with 45 degrees, but notice there's no 2 there. This is a rationalized version of 1 over root 2. So one little note I want you to make is that when you see rationalized fractions like this, that a root a over a, so when it's root number over number, like let's say root 3 over 3, that is going to be is equal to 1 over the square root of that value. So for example, 1 over square root of 2 is equal to root 2 over 2. 1 over the square root of 3 is actually root 3 over 3. So you want to be able to get comfortable that realizing that these two values are actually the exact same thing. And we're going to see this show up in a couple other problems. So this will make you a little bit more aware of what we're actually looking for. Because now we know we have a positive cosine. This is going to be quadrant 1 and quadrant 4 again. Since we're now thinking about 1 over root 2, which is the same as root 2 over 2, that is going to be 45 degrees or pi over 4. So my two answers here for x will be pi over 4, and then in quadrant 4 is going to be 7 pi over 4 since we're pi over 4 short of 180. One thing I want you to take note of here is that letter B and letter C look to be very different equations, but these two equations are actually exactly the same. When you actually find it, you're really ultimately finding when cosine of x is equal to 1 over root 2 in both of those scenarios. So we're going to see and come back to that one more time in this video. Okay, so the next idea we got to think about here is tangent is equal to 1. Now, this one's unique because a lot of times when you see zeros, ones, negative ones, or undefined, that is indicating that we're dealing with a quadrantal. There's only one situation where that's not true, and that is this one right here, because tangent is equal to 1 when it's 45 degrees. So let's answer those questions. So it's a positive ratio, tangent's positive in quadrant 1 and quadrant 3. Since the ratio is 1, that's going to tell me specifically for tangent that we're dealing with 45 degree reference angle. So my two answers for this question will be pi over 4, and then the quadrant 3 answer is going to be 1 more pi over 4 past 4 pi over 4. So that's 5 pi over 4 is my quadrant 3 answer. All right, a few more wrinkles that we need to address, and then we are going to be all set to go here. So the next situation I want to look at, and this is a great chance for you to pause and try this out, is what happens when we have an equation like this. Like all the other ones, the trig ratio is by itself. And so we have to do a few steps before we can actually do the work that we've done in the first. I need to get that secant of x by itself. So we're kind of going to treat this like a linear equation. We're going to first move that 2 to the other side by adding it. So I'll get root 2 times secant of x equals 2. I still need to get secant by itself, so I'm going to divide by root 2. And so what I end up with as my equation is secant of x is equal to 2 over root 2. Okay, that looks more like what we've done in letters A through D. So as a challenge, I want you to pause this video now and try to see if you can solve this problem on your own. Back. My hope is if you saw this, we've already talked about reciprocals, so my first step here was to turn the secant into a cosine equation. Cosine of x is equal to root 2 over 2. Now this should ring a bell because back in letter C, we solved that exact equation. Cosine x is root 2 over 2. So as we noted, that's actually the unsimplified radical of 1 over root 2, which is positive in quadrants 1 and 4, and 1 over root 2 is the cosine when you have 45 degrees. So once again, we got answers of pi over 4 and 7 pi over 4. Now, let's look at another one of these. Let's go through one, and if, again, same thing, feel free to pause this if you feel like you can tackle letter F before we go through it together. So first thing I want to do is, in these situations, we're just going to get that cotangent by itself so that we can evaluate it. So we're going to subtract 1 first, and then divide by the square root of 3. So we have cotangent of x is equal to -1 over root 3. My suggestion is then let's convert that to its parent cofunction, which in this case is tangent. So instead, I'm going to look at the equation tangent of x is equal to -√3/1 or -√3. Now we know we're dealing with a negative tangent. Tangent's negative in quadrants 2 and 4. And -√3, well, that would be -√3/1. Forget the negative. Root 3, and we want opposite over adjacent. So it looks like I'm working with 60 degrees here, which 60 is pi over 3 in the world of radians. So my two answers will be, in pi over 2, we're going to just be 1/3 short of 3 over 3, so it's going to be 2 pi over 3. And then in quadrant 4, we're 1 short of 2 pi, which is 6 pi over 3. So 1 short would be 5 pi over 3. And that's going to be our answer for that one. So with these linear situations, you want to make sure that the trig ratio is by itself first, and then proceed to go through the process that we've been doing. All right, final two questions. Letter G has a unique issue here, and that is this symbol. What does that mean? Well, that means that there are no solutions. That is a mathematical symbol called the empty set. It means no solution. As soon as you see that, the alarm bell should go up that we're talking here about a quadrantal angle. Since we're dealing with cotangent, let's go ahead and flip it. And as we've talked about in prior lessons, if you flip something that is no solution, that means it's 1 over 0 or -1 over 0. When you flip it, that's just going to become 0. So now I'm really just answering the question, when is tangent equal to 0? And the only places are going to be our quadrantals. Now, just to recall, tangent is equal to y over x. So we basically need the y value to be 0, x to be not 0. The only two places where y is going to be equal to 0 is right here and right here. So that's going to be 0 and that's going to be pi. So the y value is 0 at 0 and pi. The x value is going to be equal to 1 or -1. So in this case, my two values for tangent, the two angles that are going to work for this, are 0 and pi for my final answer. So for the last question of this video, I want you to pause and try this one out. This is sort of a combo of the last problems we've done. E, F, and G kind of merged together. So pause this, let's try it out, and that's where we'll wrap things up. Okay, if you tried this, we're going to get cosine by itself first. So I'm going to divide both sides by -3. When I do that, we're going to get cosine of x now by itself, and 3 over -3 is equal to -1. Now, thankfully, this is not a reciprocal. Cosine can only be 1 or -1 on a quadrantal. So we're going to need to now look at our quadrantal angles, right? And if you need a toolbox, there's your quadrantal angles. We're looking for when cosine, remember, on the unit circle is equal to just the x value. I know that seems kind of counterintuitive to see x there twice, so maybe we'll go ahead and put that theta there just for better conversation. So I really just need to know when the x value is equal to -1. Only place where x can equal -1 on the unit circle is right here, because of here it's +1, here it's 0, and here it's 0. So that is my only possibility. And so the value of the angle here is going to just be one answer, and pi is the answer. So sometimes you are only going to get one answer. Usually this is going to happen with our quadrantal angles, but there can be a few other scenarios where this occurs. But for majority of them, as you've seen in this video, the answers will have two of them because there are two places where a trig ratio is positive and or negative. So I think that's just about every variety that we might run into. So now it's going to be your opportunity to jump in and try some of these problems on your own, take your time, and use your trig toolbox to help you find success. Good luck, and thank you for watching.